Let's review some IMF and solution concept in this video. So the first question is, this molecular diagram shows a sample of liquid water. Which of this diagram best depicts the vapor emitted from a pot of boiling water? So we should know that boiling is just a physical change. So what happens here is when you heat the water, the hydrogen bond or the IMF, the hydrogen bond between the water molecule breaks. So the water molecule will be still water molecule. Okay, so the chemical property is not going to change. Only that attraction between the molecule breaks and it is going to be in free state and no intermolecular attraction in the vapor phase, correct? So that's what we have to look for. In the first case, we can see water molecule, still water molecule, and it is little far apart. And in the second case, we can see diatomic molecule here. So hydrogen here and oxygen here. In the third one, these are atomic. So it's a mixture of two atoms. I can say hydrogen and oxygen, correct? So in this case, this is going to be chemical change, and this is also chemical change because we are seeing entirely new substances from water molecule, correct? So we have to pick this answer. Let's see the next question. A chemist has three compounds of similar molecular weight but with a different dominant intermolecular forces. Select the compound that should have the lowest boiling point based on the compound's dominant intermolecular forces. So what we have to do here is we have to pay close attention to what is it asking is the lowest boiling point. Lowest boiling point means the intermolecular force of attraction should be weak so that it will break easily and it will boil easily, right? The boiling point will be very low. So which one is that? So we should know the strength of the intermolecular forces here. So first one is hydrogen bonding. Second one is dispersion forces. That means London dispersion forces. And this one is covalent bond. And this is dipole force. So we can see that the weakest one is LDF. And the strongest is covalent among these, and LDF is the weakest among these. And then we can see the boiling point. Boiling point will be very low for the weakest one. So these two are, we can say, in between. Hydrogen bond is stronger, and then the dipole. Okay, so the weakest one only, the one we have to pay attention now for this question. So that will be the LDF. So that one will have the lowest boiling point. Next question is, does CH3Cl have dipole-dipole forces? How are we going to decide that one is again with the shape? So what I will do, and also electronegativity difference, right? So I have CH3 and Cl. Cl is electronegative than carbon. So the electron pair will shift towards, the shared electron pair will shift towards chlorine or chloride ion. So chloride ion, slightly negative charge and slightly positive charge. So we will have a net dipole. So the molecule is going to be in terms of electron density asymmetric. So we will have a dipole-dipole interaction. Unequal distribution of electrons. So dipole-dipole interaction. So our answer is yes, it will have dipole forces because one of them is highly electronegative than other atoms. Let's see this one. For each solute, identify the better solvent, water or carbon tetrachloride. So what we have to do here is, first we have to think about the polarity of the solute particle as well as the solvent particle. So the solvent is water and carbon tetrachloride. So water is H2O and we know it is slightly negative this side, slightly positive this side. So it will be having polarity because dipole-dipole interaction as well as hydrogen bonding, right? So we call this molecule, water molecule is polar and this solvent is polar solvent. And carbon tetrachloride, we know tetrahedral shape, even though the bonds are polar, the dipole cancels. So we will have a non-polar molecule. Okay, so this is non-polar solvent. Okay, so in this case now think about the solute. So in this case we will have hydrogen and oxygen here, so and this carbon, so electronegativity difference is there, so this is going to be dipole-dipole interaction, so this is going to be polar. And in the case of bromine, we don't have any electronegativity difference between bromine, so it is going to be non-polar solute. So we know polar solute dissolves in polar solvent, and non-polar solute dissolves in non-polar solvent. So since this is polar, it can dissolve in water. This is non-polar, so it can dissolve in carbon tetrachloride. Is which solution has the lowest vapor pressure? So the vapor pressure will be very high when the number of particles are less in the solution. So the number of particles means it should be non-volatile, means it is not going to evaporate easily. So that is what is called non-volatile. It is not going to evaporate. Okay. So vapor pressure is high when the number of particles are less. So we can see here 3 particles. Here we can see 6 particles. Here we can see 9 particles. When you count that, you can see those ions. And glucose is not ionizing. So that is the least number of particles here. So this is going to be in the molecular form. Whereas sodium chloride is ionic, so it will be in the ionic form. So we can see that sodium ion and chloride ion. So the number of particles are highest in this case. So what happens is the vapor pressure is going to be lowest. Whereas in this case, the number of particles are less, so the vapor pressure is going to be the highest. So the lowest is going to be for the beaker with the calcium chloride. So that is not going to be easily vaporizing the calcium chloride, and that will block the water molecule to get into the vapor phase. That is why this beaker with the calcium chloride has the lowest vapor pressure. So now let us see the vapor pressure and the boiling point relation. Very quick, that concept is that when the vapor pressure is less, the boiling point is going to be high. So when this vapor pressure is here, is high, so the boiling point reverse, okay, boiling point will be less. And here vapor pressure is low, so the boiling point will be high in this case. Next question is, which halogen has the lowest boiling point? So we have chlorine, bromine, and iodine. So what happens when you go down in the group, the size increases. So for iodine, the polarizability is high, and for this one, polarizability is less. So when there is more polarizability, one side become negative and the other side become positive, and the temporary dipole generated will result in a higher IMF, stronger IMF. So higher LDF, stronger IMF. So it will have higher boiling point. Compared to chlorine, the boiling point will be less in this case because less polarizability. And in between, bromine will be in between. So the lowest will be for chlorine and the highest boiling point will be for iodine. Next question is, you have 500 milliliter of 1 molar solutions of NaCl, Na2SO4, Na3PO4 and Al2SO4 thrice. Which solution will have the highest vapor pressure? So vapor pressure is proportional to, higher the vapor pressure means less number of particles. So we have to look for the particles here, Na plus and Cl minus in this case, so 2 ions. In this case, Na2SO4 means 2 sodium ions and 1 sulfate ion. So that means total 3 particles. And in this case, we have 3 sodium ions and 1 PO4 ion. So that means total 4 particles. And in this case, 2 plus 3 is 5 particles. So less number of particles will have high. So they are asking high. So less number of particle is for 2 here, that is NaCl. Question is, assuming equal concentrations and complete dissociation, arrange these aqueous solution by their freezing point from highest to lowest. So freezing point highest to lowest. So how many ions? So when the freezing point will be lowest, when number of particles is high. Okay. So here we can see Na and NO3 minus, only 2 particles. Na plus and NO3 minus, and here we have 1 CO3 plus ion and 3 of Br minus ion. So 3 plus 1, 4 particles here. Here we will have 3 particles, 2 sodium ions and 1 SO4 minus ion. So 3 particles here. So we are looking for the from highest to lowest freezing point. So first we have to have the highest freezing point, less number of particles. So that means NaNO3 will have the highest freezing point, because freezing point is decreasing, right? So from 0 to -4, say for example, this is the lowest and this is going to be the highest freezing point. So less number of particles means the highest. So when you add more and more particles in there, the freezing point will decrease. So the next one is going to be Na2SO4 and then it is going to be COBr3. Next question is, which of the following molecules would have the highest melting point? So highest melting point means the intermolecular attraction is strong, correct? So we had to look for, if it is given, this is all hydrocarbons. So hydrocarbons will exist as a chain. Also I can represent here. Look at that, all these are hydrogen. So what happens is, when we write the expanded form, the surface area is increasing when you have more carbon. 1, 2, 3, 4, 5, 6, 7. So see the surface area, when it is getting longer and longer, the surface area is increasing. That means the dispersion force will increase. That means when the IMF, that is the dispersion force, increases, what happens is it is becoming stronger, intermolecular force of attraction. So the melting point will be higher for this one. Okay. So okay, which compound has the highest boiling point? So when the molecular mass increases, we know that the boiling point increases. Boiling point as well as melting point increases if it is only for hydrocarbon, means it is made up of hydrogen and carbon only, with only LDF IMF present. Okay, only intermolecular force of attraction is LDF. We can say that when the molecular mass increases, the boiling point and melting point increases. Whereas in this case, we had to look for other IMF here. We can see a chlorine electronegative element here. So we will have dipole-dipole interaction here. And in the last one, we can see OH present. So we will have hydrogen bonding. Whereas in the first two cases, only LDF, because we have only carbon and hydrogen. So which one will have highest boiling point is, the strongest IMF is hydrogen bonding. So the boiling point will be highest for with molecule with the hydrogen bonding.